the collaborative computational project in wave structure interaction. So just to start off with a little background, the CCP-WSI, it began in 2015. It's funded by EPSRC, which is the Engineering and Physical Sciences Research Council in the UK. It's led by the University of Plymouth, and Professor Deborah Greaves is the PI. And originally, the working group for the project was made up of 5 academic institutions, plus software engineers from the Science and Technology Facilities Council. And it also gained support from a large number of project partners from all across the world, academics from all across the world, and industry experts, all interested in wave structure interaction problems. The overarching aim of the project is to bring together researchers working in the field, as well as software developments and data, and hopefully provide a community-driven and strategic software for wave structure interaction problems such as offshore renewable energy and coastal engineering. As part of the work, we've been developing a code repository where we keep all of the developments, the code software developments that the community has been working on, and this is hosted on GitHub via the CCP-WSI organization on GitHub. We're also working on a data repository where we are collecting benchmarking data sets for comparisons with solutions from software, code, and experimental data sets. And we do a lot of networking activities as well, sort of similar to this event, and with training events and conferences, as well as we've run a hackathon, which was a residential week-long event where people were working on their code in the CCP-WSI code repository. We also have focus group events with industry to get an industry perspective on the WSI project, so that the work we're doing is aligned with industry needs. And as Liu Feng mentioned, I've been working a lot on some blind testing, and we've had a lot of contributions from the community to blind test numerical wave structure interaction codes against some experimental data. So the original project lasted for 5 years, and we've been fortunate enough to have our funding, have a new round of funding for the CCP-WSI, and so the new funding started in 2020, so we have at least another 4.5 years of funding to run this project, which is great. And this time around, we actually also have additional support from the COSEC, the Computational Science Centre for Research Communities. So that gives us 2 full-time people for each of the 5 years working on software engineering problems for the community, and hopefully that will help us to establish some more next generation WSI tools. So as part of this new round of funding, we've also expanded the working group, and it now incorporates 8 academic institutions in the UK, plus STFC, and the logos for the partners are along the bottom. And we've also had a lot more support from industry and from across the world, academics from across the world and industry, which is really great, with a large commitment of in-kind commitment of effort from these partners. So along with this expansion of the working group, this sort of coincides with an expansion in the scope of what we want to look at within the CCP-WSI. And we want to continue everything we've done before, but now we want to include computational structural mechanics as well. So we want to connect the computational fluid dynamics community with the computational structural mechanics communities, so that we can bring in state-of-the-art numerical modeling in both the hydrodynamics and the structural mechanics, so that we can have a truly coupled wave structure interaction simulation tools. So we have the website, which I forgot to mention, but we'll mention a bit earlier, and we will continue to have lots of networking and industrial workshops, and we're hoping that this will enable us to have this fully coupled hydrodynamic and structural mechanic modeling tool suite of modeling tools to solve some of the most challenging problems in offshore engineering and coastal engineering, and even other problems including complex free surface flows like sloshing, for example. So moving on. So these are the investigators now in the new expanded WSI working group. As I said, Professor Deborah Greaves is the PI, and you can see some of the names here. You may recognise Gavin, who presented yesterday from the University of Exeter. And now, as I said before, we've expanded to include new partners such as Lee, Tom and Mohammed, who bring in expertise in the structural mechanics area. So we're hoping to build on our hydrodynamic expertise and include experts from the structural mechanics community. So we have a website, and if you're interested in the project after this talk and getting involved, I recommend going to the website. We have news from the community up there and more information about the project, notifications about our events, publications from the community, and information about the code repository and the data repository. And also there's the contact page where you can sign up to the community mailing list and gain access to the CCP-WSI code repository. So one of the resources we're actively working on, as I mentioned earlier, is the data repository, and this can be accessed through the website, and we are developing a sort of search function on the website so that you can, or the community can, search through benchmarking data sets for WSI problems. And we're slowly populating this with test cases where we provide the full details of a test case to benchmark codes against with publicly available data sets. And we're actively working on this and hoping to enhance this and other elements of the CCP-WSI into a community resource center where it makes it easy for the community to access lots of information from the community without having to go to all around the place. Also, one thing to mention is we're populating this data repository and have a few test cases on there at the moment. But if you have a test case that you would like to include in this repository, then please do get in touch, and and we can put it up onto this database, and we think it's a really good way for you to advertise your work and make it accessible for others to download your data and reproduce your test cases. So as well as the data repository, we've also got the code repository, and this is on GitHub, hosted through the CCP-WSI organization on GitHub. It is a private repository, however, we don't restrict any access. You merely have to go on the website and using the contact form, send us your GitHub name and we'll invite you to join the organization, and then you have access to all of the code repository. And this is where we're trying to collect and port all of the WSI development, community code developments. And the dream really is to have one place where you can come and a one-stop shop for all the WSI related code developments, and it just makes it all easier to access all the great work that is happening within the within the community, and you've seen some of that already during this event. And so we're developing this code repository where we hope to collect all of this work, and we hope that this will help the community to progress faster, avoid like duplicated effort, and encourage like collaboration, because it's a shared environment for doing code development. As well as it being all version controlled on GitHub, we also have continuous integration system called Anvil, which we're hoping or is designed to reduce like problems with compiling the code if you have different local sort of installations and things like that. So we're hoping to make all of the problems with getting these different code developments working easier. So on the code repository, we have various developments, but we also have tutorials and documentation to make it easier for the community to work with these new developments. And as I mentioned before, we're working on getting all of this resource into a sort of a community resource center, so it's easy to discover and find the various things that you want to use and the information you need. We're also hoping to release the code in periodic releases, and obviously we'll be providing recognition to anyone who's like contributed to the code base. So obviously the code repository is constantly evolving with people contributing new code developments. So I just want to go through a couple of the developments that are on the code repository. So as a wave structure interaction project, we're obviously very interested in wave generation, and we've included some of the standards wave generation and absorption toolboxes like waves to foam, for example. But we've also developed new wave types such as second order irregular waves and various design waves, also current profiles. We've also worked on wave makers, so you can see the animation of a solitary wave maker here. And also we have the sinusoidal shallow water wave maker coded in there as well. We also work a lot with floating structures and moorings and power takeoff systems to restrain these floating structures, and we have quasi-static catenary moorings, and we also have the Moody dynamic mooring library developed by Johannes Palm. We've also been working a lot with a body force type turbine methodology that's coupled a two-way turbine model that doesn't resolve the blades of turbines. It uses a force field to model the turbine, and we've coupled this with the 6 degrees of freedom rigid body motion solver so that we can simulate applications such as floating tidal energy devices and floating offshore wind devices. We've also included some of the community's turbulence modelling efforts, so the stabilised Reynolds average stress libraries from Larson and Furman. And we've also done some work on sediment transport and concentration modelling. Scott Brown's work from his PhD is also included in the repository. Another thing we're interested in the WSI is parallel optimization of the code, and we've been working on various aspects of this, including dynamic load balancing. So you can see a simulation here using the adaptive mesh refinement in the OpenFOAM, and dynamic load balancing is distributing the parallel load so that each of the processors has a similar amount of load, and this speeds up the simulation considerably, particularly in cases with this dynamic adaptive mesh refinement. And then another very sort of important part of what we're doing in the CCP-WSI is working on zonal CFD multi-region solutions so that you can couple together different solvers in different regions so that you use the most appropriate tool in the correct area, so that, for example, you can use a fully nonlinear potential theory for the wave propagation, but then as the wave approaches a structure, you may require a Navier-Stokes solver to solve the viscous effects, for example. And we have two sort of versions of this. One WSI foam, which is originally developed by academics at Manchester Metropolitan University, and they have coupled together incompressible and compressible solvers in a multi-region fashion. And the second is QualiFoam, which is work done at City University, and there's an animation down here of coupling between a fully nonlinear potential theory solver called QualiFEM and the Navier-Stokes solver in OpenFOAM, which is Interfoam. So that's just a few examples of what's in the code repository at the moment. Obviously, it's a work in progress, and we hope that anyone interested in wave structure interaction and developing code will be interested in joining the community and contributing to this code base. And so, as I mentioned before, networking is a really important part of this project. It's all about collaboration and getting the community together, and now we have an expanded community of hydrodynamicists and also structural mechanics people. And we run a lot of different networking activities, including training in the use of the code repository and all of the various CCP-WSI resources. We also have sort of conferences and workshops where people present on state-of-the-art development, such as our code developers workshops. And as I mentioned before, we've had one hackathon, and we hope to have, well, we will be having some more in the next 5 years of the project. And that was a really fun event where we went to Northern Ireland, and we spent a week with a group of people working on getting their code into the repository. And then also we will be having industry events focus group workshops, various webinars and road mapping exercises with reports to disseminate the strategy for the wave structure interaction community. And again, we've been doing work on blind testing, and that work will continue, and we're hoping to have blind tests in the new round of the CCP-WSI, which start to incorporate some of these structural mechanics problems along with the hydrodynamics problems as well. And as a shameless plug, our next event is the next CCP Code Developers Workshop. It's our second one, and it will be taking place on the 7th and the 8th of April in the afternoon to enable hopefully an international group of participants. It's completely free, and it'll be online due to the ongoing pandemic. It's free, but hopefully, well, we would like everyone to register for the event to receive the joining instructions, and you can do that online. If you go to the CCP-WSI website, you should be able to find your way there, but here's the full link at the top here. And the agenda is still to be confirmed, but we are planning 4 priority themes for discussion, and there will be presentations from experts in the community, and then a panel discussion on these 4 themes: code coupling and multi-physics simulation, wave soil structure interaction and scour, and then in general improving the speed and the efficiency of simulations through parallel optimization, but also potentially through methods such as machine learning, and then modeling large deformations of complex materials. So you can see there's a real aim to include both the hydrodynamic sort of loading on structures, but also the structural deformation of the structures as well. And we're sort of including soil and sediments is kind of a structure, a complex one, but a structure nonetheless. So if you're interested in attending this, please register on the website. And that is everything from me today. And here's my contact email address if you want to get in touch, and all of the references from my slideshow. Thank you very much.